Hi guys, how you doing? I just want to finish up 4.1, and remember you have these slides at your access. Um, and just to remind everyone right here that, go and generate this right here. These slides are definitely available. We already actually talked about rand int and how you can use your calculator as a random number generator. That was in the previous workbook video. And right here, this is in the slides, and this right here is just how to use a table to go and generate. In this case, we're doing a simple random sample of 4 hotels, and we're using right here this this particular table that was given right here. So in this case right here, let me change my pen color real quick, is we would right here just read from left, 2-digit numbers from left to right. So you see the first one was 69, so that's crossed out. The next one is 5, we take that. The next one is 16, right? If you can see right there, 16, we take that. Then you had 48, you had 17 right there. All right, you take that. 87, 17 is repeated, 40, 95. All these right here are too big right here because we're only going up, notice this, from 1 to 28. And then they finally come across 20 right here. So you take 20. So there it is, Beach Castle, Radisson, Ramada, and Sea Club. All right, so that gives you, that's again how you do our simple random sample. And this was covered on the last video. All right, remember right here, and this is in the next slide, and these slides are already there for you. Just wanted to highlight that. Make sure you do know how to use a table. You shouldn't use the word table D, and when you're talking about AP statistics exam, you can just say table of random digits. That's fine. And make sure right here, if you're talking about numbers that go past from 10 and beyond right here, that you use 2-digit numbers. So you would take, for example, 0, 1 to 50 instead of saying 1 to 50. The only exception to that is, and that's if you're using a table. If you're using rand int, that does not matter, of course, okay? Like I talked about in the other video. All right, so right here, if you see this example in the slide right here, this is saying right here that someone is taking from a list of 2,500 Ford, 2,500 GM, 2,500 Honda, and 2,500 Toyota, and they want to get a sample of 400 car buyers by sampling 100 buyers of each brand. Is that an example of simple random sample? And the answer is no, it's not. All right, this is an example, if you remember from the Khan Academy video I showed, this is an example of stratified random sampling. All right, and I'm going to explain that in a second. All right, and the reason being is a simple random sample, the definition is every sample of size n. All right, in this case right here, the size is 400. So every sample of size 400 has to have an equal chance of being selected. So a real easy way of remembering, thinking about this, right? Rather than the way the explanation said, did I have an option of having maybe 1 Ford, 1 Honda, and we need 400, right? So 388 Toyota, and right here, 1 GM. I'm sorry, 398, my fault, 398 Toyota. No, that option was not there. Or likewise, I said, is 99 Ford buyers, 101 Honda buyers, 100 Toyota, and 100 GM. Is that an option right here? No, it's not. So a simple random sample, every possible sample of size 400 has to have an equal chance of being selected. So right here, what we did right here in this previous example, when you just took 100 simple random sample of 100 of each, is called stratified random sampling. And we're going to look at that right now. All right, stratified random sampling, it shows basically you're taking a simple random sample of each strata. You separate into categories. All right, and it's used to give more precise estimates. All right, cluster sampling we'll get into later. That's when actually you do separate everything into categories, but it's more by location. So you have like one location, another location, etc. And you take every single person from a simply random sample cluster used for practical reasons, saving time and money. All right, so right here, strata are groups of individuals in a population who share characteristics thought to be associated with variables being measured in a study. Stratified random sampling selects a sample by choosing a simple random sample from each stratum and combining the simple random samples into one overall sample. It works best when the individuals within each stratum are similar with respect to what is being measured, and when there are large differences between the strata. When we choose strata that have similar responses within strata but different responses between the strata, stratified random sampling gives more precise estimates than simple random sampling of the same size. Okay, so let's take a look at, and then we'll go back to cluster in a second, but we're going to take a look at simple random sample. Hey, all right, so the student council wants to conduct a survey about the use of school library during the first 5 minutes of an all-school assembly in the auditorium. There are 800 students present at the assembly. Here's a map of the auditorium. Note that the students are seated by grade level and that the seats are numbered from 1 to 800. A, describe how to obtain a sample of 800 students using stratified random sampling. Explain your choice of strata and why this method might be preferred to simple random sampling. So right here, this survey is about the use of the school library during the first 5 minutes of an all-school assembly in here. Oh, I'm sorry. We're conducting this survey right here during the first 5 minutes of an all-school assembly in the auditorium. Okay, so right here. So we think for whatever reason that maybe freshmen, sophomores, juniors, and seniors collectively, that freshmen may, maybe they'd have a different attitude towards the school library. And, maybe we think that, I don't know, they're more likely to be on time, more likely to be not on time, I don't know. Sophomores have a different attitude towards the school library, and maybe they're more likely to be on time, who knows. Juniors have a different attitude towards the school library, and seniors have a different attitude towards the school library. So what we would do for A is separate, we're going to create our strata. We have 9th grade, 10th grade, 11th grade, and 12th grade. So right here, student library use might be similar within grade levels, but different across grade levels. We're going to use the grade level seating area as strata. So we have right here, so we have, first of all, we have the freshman strata, we have the sophomore strata, we have the junior strata, and we have the senior strata. So what are we going to do? We are going to, right here, we generate 20 different random integers from 601 to 800. Now, where do they get 601 to 800? Well, they're right here, freshmen. They're seated from 601 to 800. So we're going to randomly generate 20 different integers from 601 to 800 and give the survey to the students in these seats. Then we're going to repeat for sophomores, juniors, and seniors using their corresponding seat numbers. That then gives us our stratified random sample. Now they said, what is the advantage of this? Well, stratified random sampling should give a more precise estimate of, in this case, remember, give some context right here of student opinion rather than a simple random sample of the same size. So it's a more precise estimate right here. Okay, and the reason, you don't have to say this in your answer, but the reasoning is, of course, because freshmen might feel differently about the school library than sophomores, and sophomores might feel differently than freshmen, juniors, and seniors. So each class might have a different opinion about the school library, and each class might also, be on time or not on time to a school assembly. They're doing it in the very beginning. We don't know. All right. Now, right here, let's talk about next clustered sampling. A cluster is a group of individuals in the population that are located near each other. Cluster sampling selects a sample by randomly choosing clusters and including each member of a selected cluster in a sample. So we use this right here when populations are large and spread out over a wide area. We prefer a method that selects groups of individuals that are near one another. That's the idea of cluster sampling. Cluster sampling works best when the clusters look just like the population, but on a smaller scale. Often that doesn't happen, but that's when it works the best. It's often used for practical reasons like saving time and money. So if you want a more precise estimate, stratified. But if you don't have enough time and you need to get a sample right away, then cluster sampling works best. All right, so let's look at an example right here. We're going to do the same thing. We want an example of 80 students, but now right here we want to use cluster sampling. Explain your choice of clusters and why this method might be preferred to simple random sampling. All right, so we need 80, right? So no problem. So what I would do, it might be most convenient. It's up to you how you want to do this, but I would make each separate column a cluster, right? And each column has 4 people. So we need right here a total of 80. So right here, we need a total of 80 students right here. To use right here, we need actually a total of 80 students. So let's see here. Each column of the seats from the stage to the back of the auditorium could be used as a cluster because it would be relatively easy to hand out the surveys to the entire column. Label the columns from 1 to 20, starting at the left side of the stage. Generate 2 different integers from 1 to 20, and give the survey to the 80 students sitting in these 2 columns. So right here, we're generating 2 different, right here, we're creating all these clusters. And then right here, we're just going to go ahead and, yeah, this looks a little bit confusing, but basically they just didn't write out every single thing. We're just going to, right here, they have a total of, right here, this is a total of 40 people in each of the columns. So what we do is we create all these, and then we're just going to randomly generate 2 different clusters, maybe one here and maybe one there. And then we're going to sample everybody in that cluster. All right, cluster sampling is much more efficient than finding 80 seats scattered about the auditorium as required by simple random sampling. Okay, so and again, cluster sampling is more just done by time, for time and money. Okay, what can go wrong? As we've learned, the use of bad sampling research methods, convenience, or voluntary response often leads to bias. Researchers can avoid these methods by using random sampling to choose their samples. Other problems in conducting sampling surveys are more difficult to avoid. Undercoverage occurs when some members of the population are less likely to be chosen and cannot be chosen to sample. Non-response occurs when an individual chosen for the sample can't be contacted or refuses to participate. Response bias occurs when there's a systematic pattern of inaccurate answers to a survey question. We had an example like right here when they asked about when they did a survey of graduates and they said, which of you have cheated in your senior year? Well, people aren't going to always be, honest about that. Non-response could be something like, for a telephone survey. Some people can't be contacted. Some people just, don't want to respond to a telephone survey, for example. Undercoverage, some members of the population are less likely to be chosen. So if you're doing, a certain population where some people, maybe a lot of people work at night, okay? That's a representative of undercoverage right there because you're not getting certain people in the population that are less likely to be chosen. Many students lose credit when describing what can go wrong in sample surveys because they use incorrect terminology. While it's important for students to understand and use the vocabulary of statistics correctly, they are rarely required to use specific vocabulary in the responses in the AP Stat. To be safe, tell your students not to worry about naming a specific problem or source of bias. Instead, have them clearly describe the problem and its consequences in the context of the question. So right here, vocabulary words are great and everything like that, but it is very important to clearly describe the problem and its consequences in the context of the question. All right, and right here, just a last thing here, some students misuse the term voluntary response to explain why certain individuals don't respond in a sample survey. Their belief is that participation in a survey is optional, so anyone can refuse to take part. What the students are describing is non-response. All right, that's an example of non-response. Yeah, voluntary response is a type of survey right here, but what you're actually describing when someone refuses to go and take part or someone is not able to take part right here, we're talking about that was right here. They can't be contacted or refuse to, that's called non-response, okay? Anyway, that is it for the slides, guys. So now you can actually successfully do 4.1. Have a good day. See you later.